I did put a lot of examples in this concept, in this section, because it's kind of a new thing. You've probably never heard of abundant numbers or deficient numbers. 220. We've yet to come across a perfect one. They're a little more rare. 22 and 10. Oops. I just went on autopilot and started doing the prime factorization. That's not what we're doing here. We need the proper factors. So 1 and 220, 2 and 110, 3, nope, 4 and 55, 5 and 44. We continue through until we get to 10 and 22, and then 11 and 20. And those are going to be all of our factors. I used my notes. So I know that these are all of the factors, and then the proper factors are all of those. But what if I didn't have my notes? I would just be using my calculator and saying divided by 11, divided by 12, divided by 13, divided by 14, all the way until we've circled back around. But remember, with a number like 220 that's a little bit larger, you can use that technique where if you do the prime factorization, you can see how many factors it has. We do the prime factorization. The number of factors was 2 plus 1 times 1 plus 1 times 1 plus 1 for each of the exponents there. That's 3 times 2 times 2, which is 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You know you found them all. All right, so again, just a little technique if you're doubting yourself, if you're like, did I miss any? Is something going wrong here? If you have extra time on an assessment and you just want to feel extra secure that you found all the factors, that's how you can figure it out. You know for sure how many there are. We have 12 of them, which means we found them all. 1 plus 2 plus 4 plus 5 plus 10 plus 11 plus 20 plus 22 plus 44 plus 55. Let me erase this so it's out of the way. Plus 110. When I add all of these together, I should get 284. This is a number that is larger than 220. Therefore, 220 is an abundant number. What about 284? Again, a bigger number. Let's do it this way real quick, although the multiples of this are not as nice. This is not in my notes. I'm going rogues. 284. Let's do divided by 4. 71. All right, so we do not have that many primes here, which means we're not going to have that many factors. The number of factors is 2 plus 1 times 1 plus 1. That's 3 times 2, that's 6. Only 6 factors total. All right, so as I find my proper factors, 1 and 284, 2 went into it for sure. It's an even number, so we know it's divisible by 2. 2 and 142. And then up above, we had 4 and 71. That was what I did on my prime factors. All right, we have all 6. I don't need to go check between 4 and 71. I don't need to go through all of those options. This is a great place where that theorem should be used, because that would be exhausting to sit there and try to check from 5, 6, 7, 8, 9, 10, all the way to 71. That's a huge gap. When we know now, because of the theorem, we've already found all 6 factors. This is it. So the sum of the proper factors, 1 plus 2 plus 4 plus 71 plus 142, is equal to 220, which is less than 284. That means that 284 is a deficient number.